steps to determine the amount of heat or enthalpy. So first we're gonna have to determine heat gain and heat loss in the system. Second of all, you have to set up the equation just like what we did, which is equal to heat is equal to m times c times delta t. Basically, if you need to calculate the amount of heat, you must be able to utilize the mass, specific heat, and change of temperature. Heat and enthalpy is the same because it's heat release or heat gain. So recall back to what happened when you gain heat and when you lose this heat. So, but for this one, it's a little bit different, you know. For example, if it gains heat at a final temperature, it's supposed to be a little bit higher temperature. And this one, when it loses heat, the temperature drop a little bit. You're gonna have to figure out what it is from over here in just a minute, and then you substitute this from the known value or given informations, and then you're gonna have to identify what equations it looking for, and you're gonna have to solve for it. So for this one, I'm just gonna go ahead and utilize, for example, I'm just gonna tell you what's given based on what I'm looking. Gold heated to, see? So which means the amount of heat of gold at the very beginning is 300 Celsius, and then drop into the water, which has that. So gold and water has a little bit different initial temperature, and then the final temperature it rose to, so the water rose, the temperature of the water rises up all the way to 55 degrees Celsius. So from here, I'm just gonna go ahead and you determine which one gain and which one loses heat. Okay, I'm just gonna say heat loss is over here. Heat gain is equal to heat loss. So C times delta T, right, is equal to M times C times delta T. Even though it is the same, so I'm just gonna make it different. So you have to know the heat gain, which one gain the heat. So basically this is water, this is gold, because gold shape. So on the sides, I'm just gonna make notes over here. I should be taking notes. Because water, Ti is equal to 25, Tf is equal to 45 Celsius. That's how you know. And also gold, Ti is 300, it loses heat, final temperature is equal to 45 degrees Celsius. As you can see, they have the same final temperature. So in the system, the final temperature should be the same. So now I'm just gonna go ahead and set up. So I finishing determine heat gain, heat loss by looking at the temperature differences, set up the equations. So now I'm just gonna go ahead and substitute from known values. So this is the mass of gold. So mass of gold should be over here. Specific of gold, that's what we're looking for. So I'm just gonna have two okay, this is it. So I'm just gonna have to do the differences between the temperature right here. So that would be negative 255 Celsius. That's what it is based on the gold. Mass of water, which is 50. Specific heat of water, you must recall this. Change of temperature is actually 20 degrees Celsius. Okay, and a negative multiplied by negative, it become positive. So now what I'm doing is that I'm just gonna solve this one first and solve this one, and depends on what you're looking for. So that would be 50 times 4.184 times 20. That actually give me 4184. And then 255 times 150, and that actually give me C. So from here, it doesn't matter what you're looking for. You can be looking for the mass, you could be looking for the final temperature. The way you solve for it is the same. So now you do algebra. You divide this one by itself on both sides of the equation, because we're trying to look for C. The answer should be 0.11. 0.109. You get your units. And this will be specific heat of gold. I mean, this is how you would solve for it.